right. Thanks, everyone. Good turnout tonight. A big thank you to the organisers for putting this event on and inviting me to talk tonight, and it's great to meet some of you so far. Tonight, the topic is titled, Is it getting better or is it just getting different? It's an approach to how you would evaluate if your AI and LLM system is improving as you make tweaks to whether it's the architecture, the prompts, or the context that you're passing to it. So for today's goals, ideally, you will walk away understanding why measurement is important in general for any system you're building, whether it's AI-based or not. And then we'll have an example and a bit of a demo similar to how we implemented this when I was working at Atlassian. So before we jump in, my name's Wes. I've worked in data analytics AI for about 12 years now. One of the most rewarding projects I ever worked on was in the US a couple of years ago. We were building machine learning forecasts for Walmart to predict their weekly sales at every single store for all of their fresh items. I learned a lot about that, about how you would roll out a big machine learning system with humans who take that algorithm for their daily job, and the benefits that that gives to society when you have product on the shelf for customers and for the business with reduced waste. What I've noticed, no matter where I've worked, is that there's lots of data and there's lots of potential out there for solutions, but sometimes it's hard to get to that value. The problem is rarely the technology alone. Oftentimes it's the culture, the talent, and the tech all combined. And so that's why this year I started my own business. So I'm providing data and AI expertise to organizations and leaders who want to learn more about data and how they can use that in their business. And I also coach and mentor tech talent as well. For those of you who haven't used Jira or Confluence, which I think most of the crowd probably has, but the company that built that is Atlassian. So they're mostly well known for their collaboration products, but they also have a whole suite of tools that help with developer operations. They own Bitbucket, and the team I led there most recently was involved in their DevOps space. So we provided analytics, performance and strategy, advice and measurement for a suite of tools, including RovoDev. So what is RovoDev? These days, most of you probably know Claude Code. It's the famous one on the market for generating code from prompts. Back in early 2024, Atlassian was involved in the process of building and investing in AI as well. The thinking was, we have rich context on our customers. We have their repositories through Bitbucket. We know through Jira the types of work that every developer has to do in their job. And we also know from Confluence the types of documentation they have and the architecture around a lot of the work that they plan. So the intent was to build some sort of AI-powered coding agent. The screenshot, if you can make it out, is basically how that agent would operate in practice. I've taken that from the website if you're curious to learn more. Does anyone in the audience actually use RovoDev by chance? A few of you, awesome. So it was made generally available earlier this year, but the development started almost 2 years ago now. Okay, so why is measurement important? Taking a big step back, oftentimes there's debates around direction in teams especially, or if you're building something new, where should you focus your attention first? I've seen it at Atlassian and other places where people bring their own perspective. It could be that the UX was not well enough. A product manager might think that the value of the product is not fully there, people don't want to use it. Marketing can sometimes think that the audience or the customers just don't know about this tool in the market. And so oftentimes you get caught in these debates and there's a tension and a struggle to decide what is the right thing to pursue. So data science and data in general is a way to help unblock or work through some of those tensions. With measurement, you can understand, is your output from your LLM of poor quality? are users struggling to sign up to the app in general? And that's really where you should focus your attention. Perhaps the price that the product has been put to market at is too high for the value it gives, or something else. And so the big point here is that no matter the size, whether you're doing a side project, you're working in a big company, having measurement in place can feel like an overhead. But if you set it up initially, it will help you move through. Sorry. Is that better? That's better. Did everyone catch the earlier stuff? Yeah, okay. All right, so the point of all of that is just to say that with measurement, it can feel a bit like a speed bump at the beginning to get it in place. But over time, essentially, it will help you navigate your path forward as you're building the products and taking it either to an MVP, or if it's beyond that, to customers to understand how do you improve it and where should you focus your efforts. So before we get into what we did at Atlassian, just generally speaking around this topic of measurement, I think of it as more of a evolution. So initially, if you were looking at most SaaS products, they were focused on optimizing flows. So I've got screenshots here of signing up to Jira from scratch. And so you would go through a series of steps, signing up, providing your email, validating, etc. Simple metrics would often be used to track, and apologies if I can't see that back, but basically the drop-off rates through that flow. And while that's useful, is to help people in this case understand we're really struggling with the email validation. We need to think through, is that sign-up experience the best experience? Should it be done differently? And so that was the initial product analytics type of work that would guide a lot of engineering decisions and product decisions. However, as products matured, algorithms became more of a core component of actually using the product. So in the case of YouTube or Netflix or social media apps like Facebook or Instagram, you're essentially being served recommendations. The quality of your product really depends on how good those recommendations are. And so teams are constantly iterating and optimizing to make the recommendation system better and better. And so screenshots here are from YouTube. So if you went there as a blind user without logging in, you would get nothing displayed on the home screen. That would have been a product decision to say, we don't know, or our algorithm isn't good enough to surface any types of content to you. So we'll force you to log in so we can better recommend videos for you to watch. And so the whole success of YouTube and a lot of other products in this space is around how good your algorithm is at recommending. Now, with the advent of AI, it's the same principle, but it becomes more and more challenging. We have AI systems where it's a simple chat interface, where it's a human talking to, say, a Claude or a ChatGPT that can output a paragraph, that can output a sentence. Depending on what the user prompts or asks for, the return differs. And so when you start to talk about measuring quality, you're involved in this infinite space of what is quality and what does it look like and what should we expect. In the agentic scenario, that becomes even more difficult because we have an orchestrator operating on agents. Different agents can output or should output different results. The quality of one might impact the entire system itself. So the way I think about measurement in general, before we talk about LLM quality, is that there's essentially 4 buckets. The first bucket, which we'll dive into today, is offline metrics, and that's all about quality of your output from the algorithm. In the YouTube case, it's a recommendation system. In an AI system, it's the LLM quality, or the picture generated that comes out. Online metrics are those user interactions. So as the system matures and if it goes to market and you have customers using your product, this is actually a really good sense check to know if end users are finding value, where are the pain points in the total product that you're building. We'll touch on the relationship between offline and online later. Qualitative feedback, which is surveys and interviews and looking through support tickets, is also very, very useful when you're building products in general. And finally, there's business metrics where you look at revenue, costs, churn, things like that. And essentially, my team at Atlassian, but a lot of analytics and data teams have to navigate all of these different metrics to inform where should you focus your efforts in development. So, why are LLMs hard to measure? So some of these are probably pretty obvious to you guys so far, probabilistic, not deterministic. So you don't always get the same outputs for the same inputs with an LLM. Sometimes that can mean you've got a better quality response, sometimes you can get a poorer response. That is different to traditional ranking algorithms or other algorithms where you generally can expect the same outputs for the same set of inputs for the most part. The second part is, depending on the context provided, the returns will differ. As well as that, the architecture changing, all of these things can operate and impact the results that are returned. Finally, output types, like I said before, could be a code, it could be an image, could be a conversation thread to get to the end outcome. And so when you step back and think about what do we really want to get out of this system, it depends on whether it's an interactive back and forth or if it's a one-shot type approach. And the fundamental challenge with all of this stuff is no one fully understands how they work. And so if they did, you would know how to tweak it to get the exact results that you would like. But because we don't fully, having measurement in place can help you kind of direct your attention, whether it is you need to tweak your prompt, whether it is you need to look at different model types for the product or the system that you're building. Some of you might already know, but in the industry, there is a suite of benchmarks. Whenever ChatGPT releases a new model, or Anthropic, or Google, they often have marketing campaigns around it doing better on a certain benchmark of metric. Now, these metrics are useful to help sort of roughly rank things in general sense, but they do have limitations. In the coding problem space, there's a benchmark called a SweBench dataset. We couldn't use that in the RovoDev example because it was too specific. It was built off public GitHub repositories and only had Python code. I'll get into it in a minute, but at Atlassian, we were trying to build a coding agent that would work on enterprise code bases. Often they have different code types beyond Python, and the types of architecture structures might be different to what you would see in the SweBench type data set. And so the main call out here is they're useful, but they're probably not, they shouldn't be your North Star or your major guide for knowing if you're improving on your AI outputs. All right, so moving into the framework that we had. So essentially, we developed a lot of this from traditional machine learning, for people who are familiar with that. In machine learning, you often have a training set, a test set, and then an evaluation or validation set. And so if you're familiar with those concepts, it's very similar for measuring LLM outputs in the way we built, the way we did it. So you would define a quality metric. From that metric, you would have a series that you'd have to assess as options, all have pros and cons, and then you would land on one, and we'll get into what that was in the next slide. You would then have a set of samples that are static, and you would constantly be testing and iterating and assessing on that sample set. The idea from this is keeping that static means the only other changes driving a metric are from what you've done, whether it's a prompt change, whether it's from a context change or a model change. Once you have that baseline where you compare what your current model outputs are versus an ideal state, you have a baseline, and then you basically run evaluations and changes as you're assessing what things you need to improve to make it more reliable. Okay, so jumping into that in more detail. So what makes a good metric? Unfortunately, that depends on what is the problem you're trying to solve. So if you're looking at generating code, that will be a very different type of metric than if you're trying to generate PowerPoint slides as your output, or if you're trying to write a strategy document, for example, or build some other type of agentic system. The principles that we used are that it needs to correlate with the problem you're actually solving. So in the direct example of RovoDev, we were trying to understand what does success look like for this agent we're building. Is it that it generates code that can successfully run end to end? Is it that the code is almost like a human would write? And so if we get the best human written code, we train it or assess it to be trying to achieve that level of standard. And so these types of debates are what I was referring to earlier about setting up your measurement early, because what happened in our experience was we jumped straight into testing and trying things out without really having a clear sense of what does good look like for the agent that we were building. The second part is that it should move. And what that means is as you make a change, you need the metric to change as well. Because if it's static, it's essentially unusable. You can't make a decision either way, whether a prompt change was worthwhile or if a prompt change was not worth doing. And so this requires the testing up front as you assess different options. And then the third principle, which you can only do sort of post-development, is looking about how consistent that metric of quality is versus what you're seeing from user feedback, what you're seeing from users' behaviors, whether it's return usage, repeat usage, etc. So I have a demo and a couple of slides to talk through all of these steps, but in our case, we had three types of options for our metric. The main option one was, does the code run, yes or no? So essentially you would say, if the code successfully ran, that would be a 1. If it didn't, that would be a 0. Now, the problem was back in 2014, AI wasn't advanced enough for it to just one-shot build code that would run end-to-end without any problems. I think obviously today it's much more developed and would be able to, but back then we had this problem where almost all of our example test cases were failing. And so the yes-no metric wasn't the best one for us. We didn't choose the sweep edge approach because it was too focused in on Python code only. We were building for enterprise-grade repositories and softwares. So we had to come up with an internal option. The approach we landed on was called LLM as a judge. Now, this is a little bit like well used, maybe not well understood, but we did a lot of testing to validate at the time that it would actually be a good approach. Essentially, because it's a black box, you struggle to explain if it moved, why it moved, if it didn't, why didn't it? But what benefits it has is it allows you to assess things from multiple angles, whether it's how similar it is in terms of the syntax, how similar it is in terms of the formatting and the commenting. We didn't want to have code that would penalize a variable name that would be different from AI to what a human would write. And so LLM as a judge was that balance between not penalizing for things that we shouldn't penalize for, like variable names that are different, but the intent is the same. But it still allowed us to look at the overall structure and if it was sequenced the same, like a human would write. The second step was probably the hardest and I would say most important step in this work, and that's defining your sample set. So essentially what you're trying to do here is create something that's very similar to what your system will see in the wild. a miniature version so that you can quickly run it every time you make some changes. My opinion is they should be very much human curated, and what that means is manually looking through the types of problems or the types of context that you expect the user to pass to this system, so that you have a good sense of the outputs it will return. It needs to be a big enough size, so 5 samples is nowhere near enough. 30 is probably the bare minimum, but more than 100 is what I would recommend. The reason for that is it lets you be more representative of the types of things that you think the system will see. But it also lets you then do analysis down the track around, I'm doing really well at unit tests, but I'm really struggling at bug fixes, for example. So the more variation in that sample set, the better the ability you have to diagnose where your AI is working well and where it's not. So in our case, like I said, we were intending to launch RovoDev from Jira. And so we knew that there would be Jira issue descriptions about the type of work that would be done. So that was where we started from. We got the Jira issues that had a variety of work tasks involved. We then took the code diffs from a person who actually did that work. So we essentially are building a data set where we have a Jira description, the code written by a human that did that work, and that would be our ground truth to compare with the AI output. If you're struggling to imagine this right now, I have a demo that will make it clearer. Second. So once you have those two pieces set up, you essentially are running and establishing a baseline where you score that system with your curated sample set and the metric you've chosen. You can see here on the right, it's made up numbers, but essentially for each test case you have, you would score it out with the LLM as a judge in our case to get the quality scores. You can aggregate that across 100 samples and you ended up with a baseline. So that's your starting point, and everything from there is basically referenced from that. If you have improved, you'll know it should be better than 5.5. If you've deteriorated, it should go down. And then you can understand where the system needs further support, further tweaking. In our case, at the time, we found that it was very good at unit tests, bug fixes, and documentation. Where the engineers spent a lot more time was on the development of front-end and back-end new features that were the tasks being sent. And then finally, on this framework, we can test different changes. So these are all hypothetical made-up examples, but the first row, imagine you change the system so that it would ask a question in return from a user, a clarification type question. You would compare the quality score from that change versus your baseline and assess if it improved and it was significant, then you should continue with that change. The second example is keeping the same architecture, but you change the model type from a Gemini model. I forget the version numbers right now, but from model A to model B. If the more advanced model didn't improve, you would say it's not worth the cost increase because we're not seeing much quality improvement or a more expensive run. And then the third one is, for example, if you're unsure whether you should have a master single agent system, or if you want multiple sub agents and more like an agentic approach, having this measurement in place can help you compare at an aggregate level which architecture's doing better based off the scoring system you've set up. And so the other thing I just point out before we did the demo is, as you make a change and improve your baseline, that resets your baseline. So row one, we shift the change. So the new baseline goes from 5.5 to 5.75. The second test wasn't worthwhile. We didn't ship it, so it stayed the same at 5.75, sorry. We made that final change. That was our final quality from our system, and we landed at 6.2 in this made-up example. Alrighty, is there any questions before we do a quick demo? We have time at the end as well. Okay. Alrighty. So. Yep. What's up?
Oh, no, this one can
It's not working.
not working. I can try a different way to.
I think just
Yeah, something.
okay. Yeah. Cool. So before we do the demo, I just wanted to talk through those steps in a visual form. So what we have here is 5 rows, 5 different Imagine Zero examples, all with a different task. So the first one is build a function in Python to print 5 times. When I set up this code for the demo, I wrote this code column C. This is essentially the ground truth that you want AI to replicate. So when we were doing this at Atlassian, we spent a lot more time with the engineering team looking at, like, is this well-written code? Would you rate that as a good piece of code? If your ground truth, as we called it, was not of good quality, then that's not something you want to be using to assess your AI output. So in this situation, we've got the 5 different tasks. We've got our human written code here. That is what we will compare the AI output to. I don't know if what you guys can see that. Sorry about that. Just have to put up that now. So in this script, I've got the Git repository link on the slide so I can share it with everybody interested later. Essentially, we import the different functions we use. This is just set up where we load in that example file and just talk through. So that is that now. So it's loading those 5 rows. You can see in the task, you can see the human written code there. The next step is to load, in this case, the Anthropic API. And I wanted to spend some time just talking through this LLM as a judge in actual terms. You could have landed on a metric that wasn't using LLM. You could have used cosine similarity score or some other type of score, but I think for this group, given the variety of problems you'd be trying to solve, LLM as a judge is a more generic enough use case. So the prompt I have is that you are a senior Python architect and static analysis expert. The task is to provide a structural audit comparing human code, which I've called the gold standard for efficiency, with the AI code. So it reads in the task, it reads in the human code, and the AI generated code that is the next function down. And the objective is to provide a single similarity score between 0 to 100. Now, this is very different to what we did in the RovoDev example. I can't share what that prompt was, but the intent is the same. You're trying to compare one set of code to another set. And so the evaluation criteria is, do they use the same control flow? Are they optimized similarly? And you need to penalize unnecessary or complexity. There are other ways you could have written this if you were focused on simply, does it run? Can it run end-to-end and give the same result? So that's where you as the builder have the choice to decide what is good and what do you want this system to return. And then the output will be a similarity score. So that is the LLM as a judge function. And then to generate the code, I've got two examples here of prompts. So the first prompt is you're learning Python. Your code usually makes mistakes. It's not efficient. And so write a simple Python solution for the task that's fed in. The more advanced approach would be you're an expert developer, write clean, efficient Python solution. So those are the two prompts we'll test out in this demo. So if I run that, it may take a little while to run, but basically for each of those rows, it will score or generate AI code with the simple prompt and the more advanced prompt. Let's just give that a couple seconds. I was testing this morning and from the service went down, so I wasn't sure if it was actually going to work, but it's stuck online now. So, okay, code generation is complete. So then we would compare those two sets of code, the basic and the advanced, with our human generated code, and it will score each row to give us a score between 0 and 80%. So we'll write that to the results, and then I'll just try and show that for everybody. So in aggregate, between those two prompts, if you can't see, we have our base prompt give a quality score of 66%. The advanced prompt give a quality score of 71%. So what would be good practice would be to go and look through each example in this case, because we're going to have 5, and just to manually look through how different are the codes. And you can actually see on some examples the basic prompt is scored the same as the advanced code. So in this case here, very, very similar. The one where it has a difference was the bottom one, where the basic code basically created dummy data and then did a complicated join. The advanced one just did something simple like this. So that's just to show you the process. And then from that information, someone who's like data science would say you should always do a statistical test to see is it a significant difference between your baseline and your new change. In this case, we only have 5 samples, so it definitely won't be, but that is the intent of it. So just wrap up there. We won't talk through this just because of the interest of time, but just quickly wrap through it all together. I've kind of talked through this on the talk. So my learnings from working on RovoDev were essentially jumping straight into can AI solve this can sometimes cause you to have to slow down and go backwards later on. So spending time up front on what is the right problem to solve, where should the user actually trigger this agent from is also very critical. We found out a software engineer doesn't like using Jira to generate code because then they have to take that code and move it into their IDE. So spending time thinking about where it makes sense to surface an agent and action from it is probably just as important as the quality of the agent itself. That feeds into the second point there around it's only part of the story. You can have great quality output, but it may not solve the right problem. Trade-offs are always going to be essential in this field. You won't get a perfect output ever, and so you're probably going to start to see that after multiple iterations, most of your gains are achieved in the first 10 to 20 effort or changes you make. After that, it becomes marginal gains become much harder. And the final point, which is very important, is don't be afraid to change your metric as you change your intent of the problem. So you might decide, we're not really about a master coding agent, we just want to solve bug fixes. So then the metric should change in that example to focus on what you're going after. Like I mentioned before, there's 4 layers of product measurement that I think help you make decisions about success. Offline is critical in the early development stages. You have to ask yourself those fundamental questions. It helps you see improvements and focus on where to fix issues. Online measurement becomes critical as it goes live because you can see what users are actually doing. Qualitative research is also very helpful, and business metrics essentially starts to become when you're at a mature stage product looking to commercialize it. So to wrap, is it better or different? Offline evaluation to me is a very critical starting point to guide improvements, to guide your efforts. You'll know if your changes are worthwhile from doing this, but AI quality doesn't guarantee a successful product. Keep that in mind so you don't become so one-sided on just improving the quality of the outputs. And as you change direction, be flexible. That was all I had. So thank you, everybody.